5-6, parallel and perpendicular lines. So our objective for this section is to determine whether lines are parallel, perpendicular, or neither, and to write equations of parallel lines and perpendicular lines. And we can determine the relationship between two lines by comparing their slopes and their y-intercepts. So first, two distinct lines in a coordinate plane either intersect somewhere or never intersect. And lines that never intersect are called parallel. Parallel lines are lines in the same plane that never intersect. Now you can have lines that are in different planes that never intersect, and they have a different name. That's called skew lines. Okay, but for now, think of a plane as this flat screen. As long as these lines, remember that lines go forever in each direction. So if I draw this line over here, it intersects with both of these two lines right here. It actually intersects with every line on this screen right now, okay? Because if I make them all go forever, like they're supposed to, you can see that eventually these lines are all going to cross each other, except for those two right there. Those two right there, because they are parallel, will never intersect. And this one looks like it might be kind of parallel to these two as well, but whatever. Okay. So, non-vertical lines are parallel if they have the same slope and different y-intercepts. So you can see the red and the blue one have the same slope, up 1, right 2, so it has a slope of 1/2, right? Rise over run. And so does the blue one. So the blue one has a slope of 1/2. So because they're rising at the same rate as they're going right, both of these lines, the red one's going to keep going up and right, the blue one's going to keep going up and right. They are never going to cross because they have the same slope. Okay? But they have different intercepts. This intercept is 1, this intercept is -2. Okay, so the graphs in red, 1/2 x plus 1 and 1/2 x minus 2 are lines that have the same slope, 1/2, and different y-intercepts. Those two lines are parallel. And we can use the fact that slopes of parallel lines are the same to write the equation of a line parallel to some other line. So, if I have a point and another line, I can write the equation of a parallel line. So a line passes through 12, 5 and is parallel to the graph of y is equal to 2/3 x minus 1. What equation represents the line in slope-intercept form? Well, to start, I don't know where this line intercepts because it's not going to be -1 because this line is going to have a different intercept, right? This line that is parallel to this line. It's going to have a different intercept. So I don't know the intercept, but I do know a point, and I know the slope because it has to be the same as that slope. So I'm going to use point slope form, m times x minus x1. Okay? Point slope form. So using this form, I can plug in the numbers. Y minus y1 is 5 is equal to the slope 2/3 times x minus 12. This, well, I need it in slope-intercept form, so now I'm going to distribute. So that's 2/3 x minus 12 times 2/3. It's going to be 24/3, which is 8. Finally, let's get y by itself, because that's the definition of slope-intercept form. 2/3 x minus, plus 5 to both sides, minus 3. Okay? And here's my equation, y is equal to 2/3 x minus 3 in slope-intercept form. Let's try a got it problem. So here's another point parallel to this line, which means I have a slope. Same idea, y minus y1 point slope is equal to m times x minus x1. Just be careful with the negatives here. It turns into y minus negative 1, so that turns into a plus, is equal to the slope is 2 times x plus 3. Distribute the 2 gives me 2x plus 6. Subtract the 1 from both sides gives me y is equal to 2x plus 5. We can also use slopes to determine whether two lines are perpendicular. Remember that perpendicular lines are lines that intersect to form right angles. So, two non-vertical lines are perpendicular if the product of their slopes is -1. A vertical line and a horizontal line also happen to be perpendicular, even though a vertical line has an undefined slope. So, my graph of, in red, y is equal to 1/2 x minus 1. That has a slope of 1/2. The graph of y is equal to -2x plus 1 has a slope of -2. If I multiply these slopes together, we get -1. Also notice, another trick is that they are negative reciprocals of each other. So if I start with 1/2, in order to find a slope of a line perpendicular to that, I flip it over and change the sign. Negative reciprocals, which is of course -2. Okay? So if I would start with a slope of 3/4, a line perpendicular to a line with this slope would have a slope of -4/3, negative reciprocals of each other. And when I multiply 3/4 times 4/3, I would get -1. Okay? And that's what this page says right here. So two numbers whose product is -1 are opposite reciprocals. So the slopes of perpendicular lines are opposite reciprocals. So to find the opposite reciprocal of 3/4, right? First find the reciprocal, then write its opposite. And they multiply together to give you -1. So these two lines, 4y equals -5x plus 12, and y is equal to 4/5x minus 8. Are they parallel, perpendicular, or neither? So before I can tell, I need to get them both into the same form. So I'm going to put the second line right here, happens to be in slope-intercept form already. So I'm going to take this first line and put it into slope-intercept form. So I start by getting y by itself. So I'm going to divide everything by 4. So that gives me y is equal to -5/4x plus 12/4 is 3. So next, I compare the slopes. Whoops. My slope of 5/4, -5/4, and my slope of +4/5. Well, 5/4 and 4/5 are reciprocals. One's positive, one's negative. These slopes are perpendicular. Or sorry, these lines are perpendicular because the slopes are negative reciprocal slopes. Okay? Put them in the same form. Put them in slope-intercept form first. So let's change this one. 4x minus 3y equals 9. Got to get y by itself. So subtract 4x from both sides. That's -3y is equal to -4x plus 9. Divide out the -3. That gives me y is equal to 4/3x minus 3. Compare the two slopes, that one and that one. They are reciprocals of each other, but not opposite reciprocals of each other. So these two lines are neither. Okay, they do cross because they're not parallel. They just don't cross at a right angle. Okay. Let's look at this one. So 6y minus equals -x plus 6. Divide everything by 6. And we have y is equal to 1/6x plus 1. And again, these two slopes are not the same. One's positive, one's negative. So, wait, whoops. What am I doing? Why did I divide by a negative 6? I don't know. So if we divide everything by a positive 6, and yes, now these two are the same. They are parallel. Okay. So, which equation represents the line that passes through 2, 4 and is perpendicular? So the same thing. I'm going to use point slope form. X minus x1. Okay. Point slope form, I need to know a point, which I do. Y minus 4 is equal to some slope times x minus 2. And now I need a slope. I want to be perpendicular to this slope, which means that my slope will be the opposite reciprocal of 1/3, which is negative 3 over 1, which is negative 3. X minus 2. Okay, well, all of these choices happen to be in slope-intercept form. So, get rid of that. That should be a minus. So let's put it into slope-intercept form. So y minus 4 is equal to negative 3x plus 6. Add 4 to both sides. And I have y is equal to negative 3x plus 10, which is D. So a line passes through 1, 8 and is perpendicular to the graph of y is equal to 2x minus 1 plus 1. So we start with my point slope because we know a point and we know my slope. Y minus 8 is going to be equal to the slope of something perpendicular to something with a slope of 2 would have a slope of negative 1/2, x minus 1. So that's y minus 8 is going to be equal to negative 1/2 x. Negative 1/2 times negative 1 is positive 1/2. Okay. Get a little ugly here, right? Little fractions. So we're going to add 8 to both sides, and we get 8.5, obviously, which is y. We kind of like to write these as fractions. So I'm not going to write 8.5. I'm going to write 17 over 2. Okay. So we can use these to solve a real-world problem. So an architect uses software to design the ceiling of a room. The architect needs to enter an equation that represents a new beam. The new beam will be perpendicular to the existing beam, which is represented by the red line right there. Right. The new beam will pass through a corner represented by the blue point. What is the new equation that represents the new beam? Okay, well, let's think about this. I need the slope of this line and the coordinates of this point to be able to find some sort of perpendicular line. Okay, well, let's kind of find some good points here. Oh, that one looks like a good point. That's 3, 6. That one looks like a good point. That's 6, 4. So we have 2 points, 3, comma 6 and 6, comma 4. If I have 2 points on a line, I can find its slope with my formula that the slope is equal to y2 minus y1 over x2 minus x1. Okay, so that's going to be 4 minus 6 over 6 minus 3, which is negative 2 over 3. So that's my slope. Okay, well, I now know the coordinates right there. It's 12. Let's get a little more room. The coordinates of the blue point, right, blue point, were 12, comma 10. So if I have a point, I want to be perpendicular to the existing beam. I have the slope of the existing beam. So my new slope is going to be the opposite reciprocal, right? So it's negative, so my new slope is going to be positive. And then I can figure this out by doing my same technique. Y minus y1 is equal to 3 over 2 times x minus x1. So that's y minus 10 is equal to 3 over 2x. That turns into 8, right? 3 times 12 divided by 2. Yeah, so that's minus 18. Add 10 to both sides, a little more room. And my equation is y is equal to 3 over 2x minus 8. Good. What equation could the architect enter to represent a second beam whose graph will pass through this corner 0, 10 and be parallel to the existing beam? Okay, so my slope then is going to be the same of the old beam, which was negative 2 over 3. And my point is going to be 0, 10. So I have a point, I have a slope. So I use point slope form. Y minus y1 is equal to negative 2/3 times x minus 0. Well, this one's a lot easier. 10 is equal to negative 2/3 x. I need to write the 0, and then just add 10 to both sides. So y is equal to negative 2 over 3x plus 10. Okay. Our lesson check. What equations below have graphs that are parallel to each other? Well, they have to have the same slope, 6, 6. This one happens to be perpendicular to both of them. These two are parallel to each other. What is the equation of the line that passes through 3, negative 1? It's parallel, so my setup would be y minus y1, so y plus 1 is equal to the slope. I want parallel, so that's negative 4 times x minus 3. Distribute, put it in slope-intercept form, and it would be y is equal to negative 4x minus plus 12. So subtract the 1 from both sides, we get plus 11. Equation of a line that passes through 2, 3 and perpendicular. Well, this has a slope of 1, so my new slope would be negative 1 over 1. So we would be y plus 3 is going to be equal to negative 1 times x minus 2. So that'd be y plus 3 is equal to negative x plus 2 plus 2. And then subtract 3 from both sides. So y is going to be equal to negative x minus 1. Okay. Tell whether the two numbers in each pair are opposite reciprocals. Those two are. Those two are not. Those two are not. Now they are. Now they are. Okay. Write the equations of two parallel lines. That's easy. Doesn't even matter. So it's y plus, as long as the slopes are exactly the same, the intercepts can be whatever you want them to be. Okay. And of course, we can change these and make them more complicated. We can change this to standard form. We can change it to point slope form. Okay, but as long as the slopes are the same, the two lines will be parallel. How is determining if two lines are parallel similar to determining if they were perpendicular? In both cases, we're going to look at the slope. Okay? Now, the only thing that gets weird is if the intercepts happen to be exactly the same. Now these two lines technically are not parallel. Technically, they are the same line. It is not two lines, it's only one line. Okay? So as long as we have the same slope, the lines are parallel. Perpendicular, we're still going to put it in slope-intercept form. Find the slopes. If they're different, if they're opposite reciprocals, we have perpendicular lines. And that is 5-6 parallel and perpendicular lines.